Okay, so looking at properties of logarithms, we're going to use these to kind of simplify things and make sure that when we're working through logarithms, we're making them as simple as possible. So the most important part about this is remembering that a logarithm is really just an exponent. We've like looking at this first one, we've got log 1 base 5. So that means 5 is our base of our exponent, and we want the answer to be equal to 1. So the only way for that to happen is if the exponent was equal to 0. So if we look at something like let y equal log of some base, and we want it to equal to 1. If we were to change that into our exponential form, we would have b to the exponent y equals 1. Now the only way to always equal 1, regardless of what the base is if y equals 0. So then that proves that the only way for this to happen is when we have 0 as our answer. So whenever you have logarithm and you have 1, you're taking the log 1, regardless of the base, the answer is always going to be 0. Let's moving along. Conversely, if we have the answer of 1, so if we have like log in the base and what we're taking the log of are the exact same thing, the answer always has to be 1. So if we look at let y equal log b base b, well, that's saying that b to the y equals b. Anything that's just written, we always assume that the exponent is 1, and then in this case, we've got y equals 1. Okay, so whenever you see a base and what we're taking the log of is the exact same thing, it's always equal to 1. Okay, now that's kind of a little different than if we look at this. It's a little bit harder, but not all that much. We're taking the log of something and then we have an exponent on top. Well, if we let y equal, and we've got log of b base b equals, and then x up here. Well, kind of rewriting this, then we've got b to the y equals b to the x. And the only way for this to be true is if y equals x. So whenever we've got the log of itself, like the base is the same as what we're taking of the log of, but there's an exponent there, the answer is always the exponent. It always has to be equal to that exponent because that's just the property of logs. Okay, a logarithm is just an exponent. So moving along, if we're looking at something like this now, well, this one's a little bit different. But remember, a logarithm itself is an exponent. Okay, so a log itself is an exponent. So we're finding, if I were to look at this, this is 4, and then it says log 64 base 4. So we're saying what exponent would make, or 4 raised to what exponent would give me 64? Well, that's going to be 3. And then this all equals 64. Well, same thing over here. We've got 3 to some exponent that makes 3 to the 7 or equal 27. So 3 to the 3 is 27, and that's going to be 27. So when we're looking at something like this, we've got let y equal, and now we're gonna, I like to look at this kind of in two parts. We've got log of our base equals our base to some exponent. We'll just do x. Okay, so this is going to say b to the y equals x, but then we're actually taking our exponent to that value y. Okay, so we're using y, and that's what's subbing in right here. Okay, so when we look at this whole thing, we're looking at our base, so 2 the log of our base to some exponent x. Okay, we know that this whole thing is, we're using a whole bunch of logarithms here to kind of get to our value. Well, the answer to this whole thing was this value, x. So then this whole thing has to be equal to x because we're just using that property. Okay, moving on again. These ones are a little bit harder. These proofs are a little bit more in depth. If I was looking at this, we're not going to ask you to prove these, but I'm going to show it to you. You don't have to prove it. If you want to just kind of blindly memorize, the multiplication is addition, division is subtraction, and when we're looking at the power of a power, it's a little different, but it's the same thing as exponents because that's what we're looking at. So if I was considering what we have here, if I said something like, let m equal the log of x base b, which is this first part, and then n is the log of y base b, which is this, oh, we'll change that, sorry. We've got a w there. So w base b. We are going to have then, if we look at like our exponent laws, this is just going to be b to the m equals x. And this is going to be b to the n equals w. Now, if I look at this side here, the left, we want to consider what x times w would be. Okay, so well, x times w is just going to be b to the m times b to the n. Well, then that means that x times w is b to the m plus n. Well, then kind of looking at that, we're going to just move over here. Let's write all that actually out. So if we've got log base b, well, that's it, log, and then we've got x times w. Well, that's going to be equal to log of, we've got base b, and we've got b to the m plus n. Now we know that when we have the base and the value that we're taking, we're just going to look at the exponent. So that's going to tell us that log of x times w is just equal to m plus n. That was our last law, or property, I should say. And then we can just sub in for m and n. So we've got log of log of x times w base b equals log base b of x plus log base b of w. All right, kind of looking at this next one, we know that this is then going to be log of 3, and we've got 81 plus log base 3 of 243. Now you could multiply those together. It just makes the values a lot bigger. We know I can find 3 to what exponent equals 81 is 3 to the 4. That's a little bit easier than multiplying those two numbers together and try to figure it out. This one would be 3 to the 5. And then this whole thing is just equal to 9. A little easier to see. Looking at this, it's a little harder to see these values. You can do it for sure, but if I just looked at this and I said, okay, well, this is the same as if we had 64, because 2 times 3, or 32 is 64. And then I just looked at 4, 16, 64. This whole thing's just equal to 3 instead of 0.5 plus 2.5, which is a little harder to see. All right. Now we're going to use the same process for this one. Okay, we've got, let's go. We're going to kind of, so what I'm going to do is I'm going to skip ahead to kind of this value right here. Okay, I don't want to go through the whole thing again. So we're going to have that x over w is equal to b to the m over b to the n. Okay, we've got the same values that we had before. Okay, that's all going to be equal to b to the m minus n. Okay, that's exponent laws. We're just subtracting our exponents. Then we would know that we've got log base b to the exponent b is going to be m minus n. Well, that whole thing is going to be equal to m minus n. Okay, remember we're taking this value, making them equal to that, which is equal to that, So I'm taking away this here. Okay. So now that's just going to say that log b of x divided by w is equal to log base b of x minus log base b of y. Okay, I realize I'm going through this kind of quick, but these properties are very common. It's very, very much attached to the exponent law properties that we're looking at, like the quotient and the product rule for exponent laws as well. Okay, so looking at this, same idea. This is going to become log 27 base 3 minus log 81 base 3. Log 27 is 3 and 4, so we get -1. Okay, here, same idea. We've got log base 2. We're going to do 48 divided by 3. So 48 divided by 3 is going to give us 16. And then, so that's going to be 2, 4, 8, 16. And we've got 4. Okay, just a little easier to look at. Like log 3 base 2 is a little harder than what we have there. All right, last one. Again, this one's a little harder again, so a little harder to look at. I'm just going to move it down here. When we're considering this, I'm probably, I'm going to run out of space if I move it down, so I'm going to write a little bit smaller. But what we have to consider is if we go back to like our very, very base kind of exponent laws. Okay, so if I had something like, I don't know, log, if we change this to, if we remember like b to the m equals x. Well, if we considered that as like a log, that itself would be log b, so base b, excuse me, and we'd have x equals m. All right, well, if I take these values, so that's just kind of, we're just putting that in our pocket. If I take these values and I raise them to some exponent k. Okay, now I wouldn't expect you guys to be able to do this or kind of recognize this, but this is where we're going. So this is going to be equal to b to the mk equals x to the k. All right, well, what I'm going to do is I'm going to say let, let's say y equal the exponent mk, and let z equal the entire thing, x to the k. So now what we have is b to the exponent y equals z. So if we have b to the exponent y equals z, well, if I were to put that into logarithms, that would be, that would be log, and we've got base b, z equals y. Well, we know that log base b, we know z is x to the k. Okay, in our equation here, I guess it's r, we'll call it k. It's typically written as a k. And then we know that y is equal to m times k. Well, from right at the very start, we put that little logarithm in our pocket. We know that log x to the k, whole thing, and then we know m is actually equal to log base b x and then k. So long and the short of it is this whole thing is actually equal to our exponent times the logarithm. Okay, and a lot of the times we can just find that exponent or find that logarithm a lot easier this way. Okay, just to note, when we're looking at this, this is equal to log base b x to the 1 over n, which we can then make it 1 over n log base b of x. All right, so now looking at this, this is a little harder. It's also a little harder to see because I've just do that. Ooh. And then we'll get rid of, sorry, we'll get rid of that x there, good enough, whatever. Oh boy. Okay. So if I was looking at this, I'm going to change this to log. It says write it in terms of that. So all I'm going to do is the first thing I'm going to do is I'm going to say log base a, we've got x to the 4 plus log base a y to the 5. Okay, that's my power or my product rule. Okay, I'm adding my multiples. And then now all I have to do is bring that value down, that exponent, and we've got this. Okay. If I was doing this next one, it says write it as a single logarithm. So we want to bring everything together. So again, first step, we're just doing it opposite of what we just did. So we're going to have log, and if there's no base, remember it's going to be base 10. But all I'm doing is bringing the exponents up. And then division, so it's going to be x plus 3 to the 3 over x minus 1 to the 2. Okay, evaluate this one. Okay, there's a bunch of different things you can look at here. What I would do is I would go 3, and then this is going to become my exponent on 49. So we're going to have log base 3 and then 49 to the negative 1/2. Okay, that's nice and easy because we've got 3 here and we're taking the exponent. So this is all equal. I'm just going to write beside because I've run out of room. 49 to the negative 1/2. That's the square root of 49, but we need to go 1 over the square root of 49, which is just 1 over 7. All right. Last set of examples here, really quick. Logarithms are particularly useful when we're solving these equations. Now, this is what we talked about before. This is from last year. Okay, so what we want to look at is I'm going to take the log of both sides. So if I was doing this, we'd have log 7 to the exponent x equals 400. And then I'm going to bring that x down. We get log of 7. Oh, whoops. It should be log of 400 equals log of 400. And then x is equal to the log of 400 divided by the log of 7. Now I'm not going to put this in because it's going to be a big long decimal, but that's where that answer came from in grade 11. This is the stuff that we're using now. Same thing here. I'm going to do a little bit of math, but again, actually I'll probably just leave it. First step, divide that 7 over. It's not going to divide evenly, so I'm just going to leave it. And then we're going to take the log of both sides. So we've got the log of 1.06 to the x equals the log of. Now you could make this a subtraction if you really wanted to. You don't have to. And then we're going to get x times the log of all of this. Whoops. 1.06 equals the log of that. And then we would divide that 1.6 over. So log 5.2 divided by 7, all divided by the log of 1.06. And again, I'm not going to put the final answer there because it's going to be a big long decimal and not exact. So there you go.